Every physical object is made up of atoms. You, as a physical object, are made up of approximately 6.5 octillion atoms. But, believe it or not, you're basically nothing. At an atomic scale, you'd be completely invisible, and because of that, you wouldn't be able to collide with anything. You're probably really confused right now. Anyway, this is an atom. All atoms consist of protons, neutrons, and electrons. The protons and neutrons make up the nucleus, and the electrons orbit around the nucleus, much like a solar system. This particular atom is a lithium atom. It's the one that you see everywhere. It has 3 electrons, 3 protons, and 3 neutrons. The amount of protons, neutrons, and electrons is what determines what type of material the atom is. This is the periodic table. This is where you have all your dynamite, pancakes, and taxes. Each element has an atomic number, which is this number here at the top. The atomic number refers to the number of protons, and for all neutral atoms, the number of electrons. The element with the lowest atomic number, or the fewest protons, is hydrogen, which is the simplest of all elements. It has only 1 electron, 1 proton, and no neutrons. The element with the highest atomic number is organosin, with approximately 118 protons, 118 electrons, and 184 neutrons. However, each element has isotopes. Isotopes are basically the family of the element. So, for example, hydrogen has 3 members in its family: protium, deuterium, and tritium. The protium isotope is what you saw earlier. It has 1 proton and 1 electron. It is stable and is the most common of the 3 isotopes, making up 99.985% of all naturally occurring hydrogen atoms. Deuterium, on the other hand, has a neutron and a proton, but though it's stable, it only makes up about 0.0156% of all naturally occurring hydrogen. Tritium has 2 neutrons, and unlike the other 2 isotopes, is not stable, with a half-life of less than 13 years. Also, to be clear, a half-life is how long it takes for an atom to turn into a different element or isotope. So it's basically the lifetime of that specific isotope, or element. It's not exactly the lifetime of the atom in general. Another thing to note about atoms is that they are extremely small, which you probably knew. You could fit over 50 million atoms in just 1 inch. However, it's important to note that not all atoms are the same size. Helium, the smallest and funniest atom, is about 62 picometers in diameter, while the largest atom, cesium, is about 265 picometers in diameter. So you could actually fit anywhere from 47 million to 400 million atoms in an inch. Atoms are basically nothing. Even though they're often displayed like this, they're designed just like a solar system. If you scaled each proton, neutron, and electron down to its actual size, you wouldn't be able to see any of it. This is why you'd be invisible at an atomic scale. In fact, if you could remove all the empty space in the atoms that make up every person on the planet, you could fit everyone into a sugar cube. This also raises an important question. If there's so much empty space, what holds the atom together? The atom is held together by 4 forces: electromagnetic force, strong nuclear force, weak nuclear force, and gravity. The electromagnetic force is what keeps the electrons in orbit around the nucleus. This is because the electron is negatively charged, while the protons are positively charged, and the neutrons just sit there since they are neutral. Probably why they're called neutrons. Anyway, the strong nuclear force is what holds the protons and neutrons together, creating the nucleus. The weak nuclear force controls how the atom decays, and of course gravity just pulls everything together. What is most surprising about all this is that since atoms are mostly just empty space, held together by invisible forces, it's not the atoms that collide, but actually the invisible forces around them. Thus, one surface never actually comes into contact with another. They are always separated by a small space. This is the exact reason why you can't touch anything. It might look like you're touching something, in fact it probably feels like you're touching something, but you never actually come into contact with the surface. All you're feeling is just the repelling forces, not the actual atoms themselves. And if you could remove the invisible forces, you'd be able to walk right through a wall like it wasn't even there, because there's nothing to collide with. The chance of 2 atoms hitting each other would be very slim. Of course, if you changed your definition of touch,